Good morning, everybody. Well, I'm filming this in the morning. We're just going to have a quick lesson on ratios. Okay? Now, ratios, if you can see the poster behind me, is just a fancy comparison between two things. Now, if you've ever made frozen juice, okay, or iced tea in a big container, or hot chocolate, you're using a comparison and you're using what's called a ratio. Now, if you look at my Minute Maid lime, I have what's called lime juice in concentrate. So this thing is full of lime juice. So I will dump it into a container, and then it tells me in the instructions to add 4 cans of cold water. So I would add 4 more cans of this full of water. And that's a ratio. That means 1 can of concentrate to 4 cans of water. So if you look at our little poster up here, we have different ways we could write the ratio. Okay, so ratio is a comparison of numbers and quantities that are measured in the same unit. So you could write it A colon B, or write it A to B, or like a fraction A over B. And they're all read as A to B. Okay, so we have different types of ratios within the ratio. So if you look at my little picture here, okay, I have 3 asterisks and 2 triangles. And when we're comparing them to each other, we call that a part-to-part ratio. So I have 3 stars or asterisks to 2 triangles. Or I have 2 triangles to 3 stars. So that's comparing them to each other. And then I have another one, which is comparing part of your ratio to the whole or the total amount. So my ratio would be 3 to 5, because if I add the 3 stars and the 2 triangles, I have 5 in total. So I have 3 stars to 5 in the whole group, or 2 triangles to 5 in the whole group. So that's what a ratio is. It's just using information and comparing things together, and based on the number of them. So for example, in a classroom, there are 17 girls and 16 boys. So we're doing a little comparison. So our 2 part-to-part ratios, so P to P, are 17 to 6, so 17 girls to 16 boys, or 16 boys to 17 girls. You don't have to write the comparison what they are. You just need to put the numbers with the colon. And if I'm doing the part to whole, the total number of students in the class is 33. So then 1 part to whole would be 17 to 33, which is comparing girls to the whole class. And the other part to whole would be 16 to 33, and that's how many boys are to the whole class. Now, some of this stuff seems like you wouldn't really use it ever, but my example of frozen lime juice is when you use it a lot. Or if you're baking and you need to make multiple recipes of, say, cookies, that's when you start using your ratios, and that's what will give us our equivalent ratios. So they really describe the same comparison, but just in a bigger number. And if you remember from my marathon 18-minute video on fractions, we did have equivalent fractions, so they are very similar to equivalent ratios. So if I have a ratio of 2 to 5, and I want to blow it up 3 times, I would multiply both numbers by 3, so then my new ratio is 16 to 15. Okay, and same with the 7 to 12. If I want to make it an equivalent ratio of 14 to 24, I just multiply them by 2. So that's how you get your equivalent ratio. So when you are going to be doing your assignment, it may ask you to draw a ratio. Say they want you to do a ratio of 4 to 6. Okay, you can do any kind of stuff to get 4 to 6. Okay, pick something easy. I'm going to do 4 circles. All right, so I've got my 4 circles and I need 6 squares. Okay, that's a ratio showing 4 to 6. Or I could use x's. To triangles. So that's showing me different ratios. So this ratio right now, the 4 to 6, is a part to part. So they will tell you part to part. All right? And this is how I demonstrate it. If they're doing a part to whole, they'll give you a bit more information so that you know how many or what your other shape may be. So if I wanted to do a part to whole, I'm running out of space here. The part to whole ratio would be 4 to 10. Because there's 10 in total. Or 6 to 10. Because there are 10 in total. So ratios really just involve a lot of counting and drawing. And if you're needing to do an equivalent ratio for, say, 4 to 6, I say just double it. So I would multiply each side by 2. And that will give me an equivalent ratio of 8 to 12. So your assignment's on the Google Classroom. You only have to do a few pages. And next week, we'll be learning about scale, which is the most common use of ratios, whether it's scales on a model, scale on a map. So you will be getting into more in-depth ratio review. And that's that. Let's see. 8 minutes. So that's a lot shorter than the last one. So anyways, goodbye.